So here I plotted the points, negative 8, 1, and 4, negative 6, okay? And using Pythagoras' theorem, we know if we do a squared plus b squared equals c squared, we can get the distance. And of course, c squared is the length of xy. So we're going to draw our right triangle. I wanted to change colors here so that way it's a little easier to see. Okay. And of course we count the length of the leg. Now this leg that is vertical goes from positive 1. Let me do it in red. It's a little easier to see. It goes from positive 1 down to negative 6. So we know that the length of this leg is 1, 2, 3, 4, 5, 6, is 7. Okay? And then to find the horizontal leg, we're going from, let me erase this and put this over here, so it's a little less confusing. The horizontal leg goes from negative 8 to positive 4. And that is a length of 12. Okay? Now, a squared is the shorter leg going from, which we know we would plug in 7 squared, and then we would plug in 12 squared. Okay, that's what we use Pythagoras' theorem for. We use it for solving the side lengths. But if you notice, the 7 squared, comes from taking the difference between positive 1 and negative 6. So I could substitute that in. 1 minus a negative 6 gives me the length. And then the 12 squared, of course, we get by taking the difference of negative 8 minus 4. Because a negative 8 minus 4 does give me negative 12. But of course, when we square it, we get a positive number. So if we go back to our original problem, there's nothing that says I can't do 4 minus a negative 8 and a negative 6 minus 1. Both. All I did was reverse the x, and what x listed was listed first and what x and y was listed second. We still get the same answer. Question number 8 is asking you to determine which formula will allow us to find the distance between 2 points on the coordinate plane. Now, I'm sure this looks a little different to you because you may not have used the distance formula when solving this. Because the other option is to use Pythagoras' theorem. which we used on graph paper. But let me show you, sorry, wrong way. You'll notice so here is, okay, we wrote it as 1 minus a negative 6 and negative 8 minus 4, okay? But when we're adding, it doesn't make a difference. So essentially, because we can interchange, because whether I do 2 plus 3 or 3 plus 2, I still get the same answer. So it doesn't matter. So that is same thing as using Pythagoras' theorem. The only difference is that we're using the actual coordinates, the difference of the x values and the difference of the y values. Okay. Now it also asks you to select all that apply. Okay. So if we go back to our, and unfortunately that is what this question is trying to get you to see, that this is the exact same problem, just these numbers reversed. Same thing. So the two formulas that would allow you to find the distance are A and D. A little confusing because I apologize. I taught you how to do it using Pythagoras' theorem. But just know that those values of the legs, 7 and 12, come from taking the difference of the x and y values on the coordinate plane. Oops. Okay. Next is the coordinate of x on PQ is 5/6 of the distance from P to Q. Okay, so where our last question asks us for the total distance, this is asking us for a portion of the distance. Okay, so first thing we need to do is determine what the total length of P to Q is. And so if you notice, -5 to 0 is 5 units, and 0 to 7 is obviously 7 units. So PQ has a length of 12. So to determine where or what 5/6 of 12 is, we have to multiply. 12 times 5/6. And remember, when we multiply by a whole number, we put that over 1. Now, you can multiply straight across. So 12 times 5 is 60. 1 times 6 is 6. So 5/6 of 12 is 10 is 10 of 12. So if this was in inches, it's really units because it's on a number line. So 10 units represents 5/6 of the total 12 unit length. Okay. You could also recognize that if you do 12 over 1 times 5 over 6, 6 goes into 6 once, and 6 goes into 12 twice, giving me 10. If you don't recognize it, that's totally fine. Just do what you're used to, multiply straight across, no big deal. But I also wanted to point out that if you recognized being able to cross cancel, you can do that as well. answer's still the same, okay? My answer is 10 units, okay? But if you notice, 5, 6 is 10 units, not the coordinate of point X. So to find out, to determine where point X is going to go, we're going to count 10 units from our starting point of P. So we know this is 5. And so 10, for a total of 10 units, we got to go 5 more. So 5 and 5 is 10. And so point X would go at 5 on the number line. So when we're finding a portion of a total distance, take that total length, which is in green, we found out was 12. Then multiply it times the fraction to find out how many units of the total length represent the coordinate. And then that's where we have to count 10 units from point P. And that's where, so our final answer is coordinate 5. That's where X would go.